Okay. Hello everyone, good afternoon. It's Omkar Joshi. I will be conducting this today's live session. So same mechanism. Whoever has doubt, please raise your hand. We'll have a discussion. Yes, Mehak.
So, can you explain hashing? And I also have one question, like when there's an inbuilt function called hash in Python. So whenever I put a list or anything in hash,
Mhm.
it gives a really big number, like 215468. What does it mean?
Correct.
Like,
Okay. See, hashing is like a coded you can say a coded version of whatever input you give, right? So hash function can have, I mean, can will be implemented you based on some number you give as an input. Okay, and what hash function will do, that completely depends on how the hash function is designed. So the simplest hash function, let's say, okay, you give, let's say, input is as x, and hash function, what is supposed to do, it is just supposed to do x plus 5. So it's, the hash function can be as simple as that as well, or it can be as complex as you make it. So hash function is just, takes the input, applies some some function, some mathematical function over that input, and gets the output. That's what the hash function is. It is just one function where some computation happens based on the given input. That's the basic idea behind hash functions.
what's the use of it? What's the meaning of the name?
Okay, so the hashing or hash functions are introduced in this course specifically for one Python dictionaries use hashing internally. Okay, so the thing is, we have been saying this from computational thinking, and then you must have heard it in Python and now in PDSA as well. The irrespective of which element you are accessing from dictionary, the time taken to access that element is constant. Okay, and we do not have actually sequence as such, right? I mean, if you are trying to, let's say, if we consider list, if you are accessing an element from zeroth location, I mean, not accessing, if you are, let's say, try doing some modification, inserting element, or any kind of manipulation, if you are doing with list, then if the element is at the beginning of the list, right, the time will be different. If it's in intermediate element somewhere in between, the time might will vary. And if the element is at the end, the time will vary, because whenever you access or whenever you iterate over a list, right, it's a sequential processing. You go from zeroth index to n minus 1, right? So that iteratively it happens in a sequence, because it's considered as it comes one after the other. There is a standard sequence over there, but in terms of dictionary, this sequence concept is not there. Just elements are stored as pairs, right? Keys and values. But we cannot say, okay, this pair comes before the other pair. That that senses that thing is doesn't exist in dictionary. It's just a collection of values where every element, or it's a collection of elements where every element consists of two things: key and value. But we cannot say, okay, element x appears before y. It's wrong if we say with dictionary, but if we say with a list, that's true. So why that happens? Because the dictionary, the elements or the values in dictionary are stored using some concept called as that hashing tables. And that's something which sir has introduced in one of the lecture, where he explained that how dictionaries values and keys are stored in the memory using those hash tables,
Yes, so
right?
could you just explain hash table?
Okay, so okay, let me take some example. Okay, can you see this plain notepad?
Yes, sir.
Okay, so I what I will do is, I mean, what not just me, any hash function. What hash function is, some function will be defined in terms of just, it's just like any mathematical function, right? So let's say I've defined it like maybe like this. This is my hash function. Okay. So what happens is, whenever you give any input to this particular hash function, let's say this time my input is 10. So what you will do, what is the hash of 10? You will simply apply this particular given equation over the input. Whatever the output is the hash of that 10. Are you getting?
Yeah.
So what you will do, simply 10 plus 5, 15 mod 11. What is 15 mod 11? Mod as in the modulus operation, what we do usually, right?
Remainder.
Yeah, remainder. So what will it be? It will be 4, right?
Yes.
So the hash of 10 is 5 in this case, because this is my hash function. When hash function changes, my hash value will also change, and that's exactly what is happening. I mean, and because of that, I mean, okay, this is what the hash function is. Okay, so what happens is, in hash table, right? If it's a tabular structure, so if hash of 10 is, let's say, computed to be 4, so at fourth location, okay, so at fourth location, I will store 10. So it's just a tabular structure, right? So at fourth index, I will store 10. Okay. Before going to that, have you watched this lecture?
Yes, sir.
Implementation of dictionary in Python.
Yes, all lectures.
Okay. Okay. Then maybe if you have watched, then let me refer to those same slides, and maybe I will focus more specifically on dictionaries. Then hold on. Before that, Ankur, do you want to finish that off, or you have time? You're gonna wait.
Hey, hey, I'm here. You complete this,
Yeah.
then we will take that one.
Okay. Okay. Sure. Let me present the slides. We will go ahead better with that. Okay. Okay, so the term which we have been referring is this random access, right? This is what I was telling you. Irrespective of which value you are trying to access in dictionary, it always takes same amount of time. Okay, so this is what I mean. This is general idea. This is that hash function, and at the end you get some hash value out of it. Okay, sir explained about SHA-256 and all that, but that is a different story.
Yes, I didn't
Okay.
understand what was S prime in that.
Okay. Okay, this is what you're saying, right? This S prime. What is S prime, right?
Yeah.
Okay. So the thing is, okay, well, if I go back to that previous example, what I was telling you, right? That uh, if I implement that particular hash function x plus 5 mod 11, then for a fact that f of 10, right? That means I'm trying to get a hash of 10. It gave me 4, correct? But again, there are many such possibilities where the computed hash will come out to be 4. Correct?
Yes, sir.
I mean, for different input, the hash value, there is a very, I mean, it's obvious. It's very obvious that for different input, the computed hash will come out to be 4. Correct? Because we are doing mod 11. Right, so what all possibilities are there with hash? It can be from 0 to 10, right?
Yes, sir.
So all those possibilities are there. So instead of 10, let's say if I do if I do reverse engineer, 22 minus 5. Okay, if that's my input, let's say my input is okay, now you cannot see that screen, but anyway, just you're getting my point, right? If I do, let's say if I'm trying to compute hash of, let's say, 17, what will happen? I will do 17 plus 5 mod 17 and 4. If I'm calculating it for 21, Okay, hash of 21, f of 21. What will happen? I will do 21 divided plus 5. That will give me 26. 26 mod 11 will again give me 4. So f of 10 is 4 and f of 21 is also 4. Correct?
So there is collision.
There is a collision, and that's exactly what sir is trying to say here.
And so what does this mean? X mod is less than S mod.
S, where you're seeing it?
Starting of the line, X is less than S.
Okay. So this is with respect to the map set values of S. Okay. So this particular hash function is, let's say this hash function S gives you the X. Okay. So typically what sir is trying to say is the number of X you get, right? Number of these hash values you get are going to be lesser than all possibilities of inputs. So for example, as I was explaining right now, right? What are, if I'm doing this X plus 5 mod 11, what all possibilities are there with hash values from 0 to 10, right? Whereas if I consider that input f of x, the set or the all possibilities of values which I can replace with x is huge, right? I mean, it's practically it's infinity, correct?
Yes.
Whereas the output values after hash are limited. Of course, I mean, it depends on our hashing function. As the hash function changes, all possibilities or the set of such values will vary. But still, definitely that is going to be always lesser or much smaller than all the possibilities of values which we will give as an input. So that's what this array, that's what this particular thing is. See what it says, s of x. See, if apply hashing function on s, we get x. So that's what it is. S is our input and x is the hashed value after implementing whatever hashing function is. So what the point says, maps a set of values s to a small range of integers, which is x. So this x is that range. In this case, if you're doing mod 11, then this range is from 0 to 10, which is much smaller than what all possibilities can be there for s as an input. This what s can be? It can be from minus infinity to plus infinity, right? Whereas the output, which is the output of hash, will range only from 0 to n minus 1, which is in this case 0 to 10. And because of that, there is a possibility of collision. And that's what this is. So h of s is some input with s, and then s prime is just some another input. Okay, you can even take, instead of s, you can use some different variable also. That's not an issue. So what I'm doing is, this is h of 10 is equal to h of 21, right? Because h of s is 4 and h of 21 is also 4. Whereas s and s prime are not equal because this is 10 and this is 21. So when computed hash is same, even though the given input is different, and that is the place we call it collisions. And when there are collisions, we have to find a different location for that number to be stored because it's already filled with something else, right? And we already have one question based on this principle. I think there is one programming question in practice programming question is there, right? Where already some location is filled.
Objective.
Sorry, yeah, objective question is there on this, right? Where I think computed hash is 4 and that location is filled. So you check for 5 and again 5 is filled, then the final answer is 6, I believe, right? Right, Ankur?
Yes. So there the hash function is very small, like a very simple hash function, mod 7. So if you solve that, you will understand whatever Omkar was just saying.
So maybe I will go.
It is exactly the same concept that you are that was being explained just now.
Okay, so this is that question, right? Mehak?
Yes, sir.
So what is happening? See, same thing here. H of x is x mod 7. I just took different example, x plus 5 mod 11. I just see. So there is no standard hash function available. Okay, hash function can be any function, whichever you like. So as per individual requirements, as per the application for which the hash function is going to be used, we can design our own hash functions. So as you said, right, the Python has some hash function, it gives me some large number. So Python has its own implementation of hash function. So of course, it will not be as straightforward or simple as this is x mod 7 or as I was explaining, x plus 5 mod 11. It will not be that straightforward, but there will be some standard function which is implemented over the given input. And after that, you get some output, and that is what it is printing to you. So you're initially you said, right, you give some list as an input and apply hash over it, it gives you some big number, right? So that is what Python is doing. Python is implementing some such hash function over your given input, and whatever the computed answer is, that's what it is printing.
Why do we need hashing? Is it so that we can quickly access the values in a constant time?
Yes, correct. So this part is correct. So the point is, okay, if I create, okay, as I said, what all possibilities are there, even I'm talking only with numbers, okay? Forget about characters and different combinations of characters. I mean, alphabets and numbers and special character, that's a different ball game together. I'm just talking only pure numbers. And even numbers range from minus infinity to plus infinity, right? There is no limit over that. And if we decide, design a structure where we already decide, okay, if we get so and so number, it will go at so and so location. If we predefine something like that, can you imagine what will be the size of such table? If I say, okay, I receive value 7, I will always, no matter how many times or where I get it, if I get value 7, I will always store it at, let's say, location 4, if that's my strategy. For every such value, if I've created such places, right, where I will store, okay, 7 comes, it goes at 4, 9 comes, it goes at 11, some strategy. Imagine, I mean, there is the table will not be a finite entity, right? Because there are n number of such possibilities. Hence, we apply some hash function to limit all these possibilities. So as that particular slide says, right, your input S is infinity, but your output of hash, which is in that case, it was X, is very limited and very finite. So you create a tabular structure with those many, vacant areas there. So for example, in this case, consider a simple hash this, where X mod returns the remainder when X is divided by 7. So how many possibilities are there? It is always going to be 0 to 6. So we can create a table of size 7 from index 0 to 6. So whatever number comes will always will be placed within those 7 locations available.
But sir said that
Yeah.
we need to have extra space in the array, so we can cycle around. So if there's an element already because of collision, then we can skip and we can go to some other space which is available.
Correct.
So we won't have a array of size 7, but maybe a bit larger. Right?
No, see, array of, see, that's what, see, there will be a collision, right? When collision comes, what we do, this is now open addressing, close hashing. I think this is something, it's there even in lecture, right?
Yes.
So this strategy is implemented only when there is a collision. If there is no collision, there is no worry. If collision, there are two ways. Either we can go for open hashing or closed hashing. I mean, open addressing is called closed hashing, or we can go for closed addressing, which is that open hashing. I mean, it's a bit confusing, even sir mentioned, but we can implement either of the strategies, right? When there is a collision.
So when collision happens, then only create space.
See, Okay, when there is a collision, then only we have to think about what to do, right? If there, whatever computed hash value is some value is computed, and at that specific location, if that place is vacant, we can easily place our information there, right? The problem arises only when there is a collision. Otherwise, okay, computed hash is 4 at fourth location. Okay, the value it's empty. I will simply place that value and I'm done. But when there is a collision, I have to implement some strategy. Okay, I wanted to store this value at this location, but that location is right now occupied by something else. Now I can't replace that value. That means for my new value, I have to find new location. And how to find that new location is decided based on this one of these strategies. Dealing with collision can be done either using this open addressing or open hashing, right?
Right, sir.
Right. So either of strategies we can implement and find the secondary location for it. It's just like I think sir also took the same example. I'm not sure. You go. I mean, you go to some place. I mean, you are let's say booking a movie ticket. Okay. You already have something in your mind. Okay, I want XYZ location because I prefer that location to watch movie. But you went there and you found out, okay, that location is already taken. What you will do, you will have your own some strategy. Okay, if that location is not there, then I want this. If that is also not there, then I want third one. If not third one, then fourth one. So you have these backup plans with some logic, right? But that's your logic. Same logic will not be applicable to other person may have his or her own way of choosing seats. Similarly, it's the same mechanism. There is a collision. You are trying to put some value at some location, but that location is already occupied, so you have to find a new location. How to find that new location has that depends on which strategy you are implementing. And that is what the dealing of collision is all about. And finding, I mean, these locations and all this is stored in hash table.
Okay. And so just
Okay.
one last question. What's
Yeah.
the difference between Python array and numpy array, and why numpy array takes more time than Python list?
Okay. I think this is also there in the lecture. I'm sure. Have you watched the lecture? I mean, sir explicitly explained this in a length. So
I have a bit of confusion.
okay. Can you, okay, before me explain, can you tell me what you understood? What is the difference between these two? Because he actually, I mean, not that detailed, but briefly we have explained this in our Python course as well. So can you just tell me what you understood, and then maybe I will, I will correct you if you are going wrong anywhere.
So Python list is not a list, it's actually an array. And numpy array, so we can also get arrays from Python library function named numpy. And so we use numpy array for 2D matrices or anything like graphs. It's easier to
Correct.
compute, but
Mhm.
we don't use that for Python list because it's hard to create that even, and there are many confusions like he gave the example of that when we change 0 in one location, it changes in other locations as well. Sometimes we can do this mistake. So to avoid that, we also use numpy.
Correct, correct. This part, whatever you said so far, that's correct, absolutely. But what is the difference between array and list in the first place? Forget about Python. In general, irrespective of any programming language, what is the difference between these are two different data structures? Okay, array is a different data structure, and list, or sometimes referred as linked list, are two different data structures. What is the difference between these two data structures? Have you understood that part? Because that's the idea behind whatever you just asked. I mean, that's the logic behind this difference.
Yes, sir. So lists are basically collection of nodes. So a node has a value and a pointer which points to the next node, and all
Correct.
of these nodes are not contained in one place. They are different places, so they're spread it out. And
Correct.
uh, in array, it is like
Hello.
Yes, sir.
Yeah, array is a
In array, we can have random access because we have to
okay,
walk to walk
correct.
node.
Hmm.
We can quickly get the value in an array, but in list we have to walk down, so it takes a lot of time in list as compared to array. So if you want to search,
Okay.
it's easier in array. But insertion, deletion, everything is much more easier in list as
Mhm.
compared to array.
Correct. So this part, whatever you have said, it's absolutely, I mean, correct. I mean, you're not made even a slightest mistake in explaining any of these things. So that part is clear. Okay. Still you have a confusion between NumPy arrays and Python list, right?
Yes, sir.
Okay. So the thing is, NumPy arrays are simple arrays. Okay. Whatever you concept explain about arrays, it's a continuous memory location. So if I have an array, if it's a one-dimensional array, if zeroth index appears at if any location, the first index value will appear immediately next to it. It's just a continuously allotted in the memory. Correct? That's array. The NumPy array is absolutely the array concept which you just mentioned. There's nothing, no confusion about it. The confusion is because with respect to Python list, right? We call them list. So we expect them to be linked list, but internally they are not lists. They even Python lists are internally implemented as arrays only. And that's what sir was trying to explain. Okay, we may call it a list. We may use it as a list. I mean, if you, I mean, you have all the all the functionalities of list or standard functionalities, whatever are available with list, they all are available to us. That's why even insertion and deletion we can do quickly, right? But actually internally these Python lists are implemented as arrays only. Only difference is initially it allots some X amount of memory for that array. When you create a list, it allots some X amount of memory to you. But as you keep appending into that list, there is a chance, right, that your requirement of memory exceeds the allotted memory, which is very much likely to happen, right,
Yes.
Mac? Yeah. So in that case, what happens is it will doubles the size of existing one. So for example, if initial size of, if initially some X MBs are allotted to you, it will double it to 2X MBs. And if you exceed that size also, then it will be made 4X, 8X, and so on. So the thing is, because of that, this doubling happens only when, when we exceed the allotted limit. It will not happen every time when there is an append operation. Once in a while, you will exceed the memory and the memory will be doubled for you. Okay, so this operation is costly, absolutely, because you have to move the current data, because currently at some memory location it will be allotted. At that same memory location, double size may not be available. So computer, or in fact your operating system, will have to do some internal processing in order to make that much memory available to you, some that much address, that much storage available to you. So those internal things will happen, and that's costly. Of course, the time taken to do all those things takes time. But the point is, it will not happen with every append operation. Are you getting? For example, initially you are allotted a list of, let's say, size 10, for example. Okay, just some random number I'm taking. So it's 10. So for first 9 insertion or append operation in that list, there is no problem, because you already have 10 locations allotted to you. When you do that 10th one, or maybe if you do that, when you do that 11th one, when you don't have that space but still you are doing trying to do append, what computer will do? It will simply double the size. Instead of 10, it will make it 20. So for next 10 appends, there will not be a problem. Next problem will come when you try to do that 20 for one number append operation. And that time again, it will be doubled. It will be made to 40. So again, for next 20 operations, 20 appends, there will not be a problem. So this, whenever you exceed that limit with this append operation, Of course, there is some overhead. The computer or the operating system will take some time internally to accommodate that additional memory, but that happens very rarely, because every time new memory gets created, it's doubled of previous one. And because of that, we don't bother too much about that. So that's why the term is amortized. The cost taken for the doubling, if you amortize it across all elements, it's big of one for each element.
So it takes time to double it.
Yeah, it takes time. Absolutely, it takes time. But thing is, it doesn't happen for every append. It will happen occasionally, right?
So what I understand is it is like a list only, but when it comes to memory, it is like an array, right?
Yes. So the way we access it, the way we process it as a programmer, we consider it as a list, but internally Python treats it as an array.
So that is why insertion deletion is very quick in Python list.
Correct. Okay. So the confusion is because of that. That we call it list, it appears as a list, but only internal implementation is not actually list, is array only. Okay. Yeah, sure. Thanks. So next person, I am gonna slightly off the sequence because of some reason, you will know. So Cherian, yesterday you had some discussion with other my other teammate with Rajat, and I came to know that there was some incomplete discussion happened, and some more clarity was required. So yeah, because of some discussion was happening on discourse, and we thought it's better to continue on that. So Ankur is also here. So I believe you guys had some discussion on discourse specific to one question, right?
Yeah, that is week 2 GRPA 2.
Correct. So
I just wanted to know 3-4 questions regarding that.
Sure. So sorry others, that's something which is a continuation from yesterday's live session. So let me close that, and I will come back to original sequence of raised hands. All right. So please don't mind me. So Cherian, please go on. Ankur is also here. We can continue that discussion.
Okay.
Ankur, are you able to hear?
Yes.
Yeah. All right. Go on, Cherian.
Yeah. First thing is, I wanted to know why that program is run 20,000 times to measure performance.
Okay. So we ran it 20,000 times because we wanted a substantial thing to measure. If we don't run it 20,000 times, the efficient solution, suppose it runs in 200 microseconds, and non-efficient solution, it runs in 400 microseconds, right? So that is not a good way of comparing, just putting a timeout of 200-300 microseconds or something like that, because there can be other overheads that any student may have written a program that may be inefficient, but its order may be log n. But if it is inefficient, it will take more than 500 seconds once. Okay, but when you run it 20,000 times, those factors won't be multiplied. Correct?
Okay.
Because
what I understand
we cannot.
is,
so the thing is, generally these things should be tested on very big lists. Even a list of size 1 lakh is not very big, right? So we have to take a list that is big enough, but we have some limitations on that. So we could not do that. That's why we are running it 20,000 times. You can understand it that way also.
Okay. Just 20,000 times on the same list.
On the same list.
I will tell you the why specifically 20,000 on any such high number. See, there are multiple solutions are available for some problem, right? One, let's assume for one solution takes log n computation, whereas second solution takes big of n. So there is a difference between log n and n, but it can be measured easily when there is a huge margin. If your input is very small, you cannot, you cannot judge that based on one small minor change. I mean, there will be a very small fractional change between the time taken for computation. That's why even in lectures, if you see what professor is doing, he's executing all programs with some very high, huge numbers, right? 10 raised to 7, 10 raised to n, or even maybe even higher numbers. Then only you will easily see the difference between time taken with different different implementations of same problem. That's one way to compare two different solutions based on their complexity. That's one. Or other way is to execute same thing multiple times and just amplify the factor. So it can be done either ways. So in the portal, if I be honest, that what we give is the input, right? If you are giving a list of, let's say, 1 lakh size, 10 lakh size, or even more than that, it's just an input list. So the issue is every every software, every application has some limitation of size of input and size of output. So we have some restriction with our portal that the input size of a list, or just in general input size, should not go beyond this limit. Okay. So because of that restriction, we cannot increase our input size beyond certain limit. And because of that, we use the maximum whatever is allowed to us. But beyond that, if you want to multiply that factor, then we have to execute same code multiple times. That's the only way we have. Of course, we can increase the input size, but sometimes that's very dangerous, because many things can go wrong when you increase such inputs. And creating such test cases is also not an optimized solution, because we are not processing some gigabytes of data or something. So the point is just to check whether your return solution is of log n or n. I mean, just for example. So we just wanted to categorize your solution in either of these, in either of the complexities. If it falls in one category, your half of the or partial private test cases will pass, and you will get partial marks because you wrote a solution which is correct. Only thing is not optimal. So we will not penalize you, will not give you 0 marks. You will get partial marks. But those who have written the solution and also it is optimized, then all test cases will pass and you will get full marks. That's the logic or idea behind this, execution of 20,000 times or so.
Okay, sir. Then one more doubt I had is with respect to a response, that is in Python, list slicing is usually an big O of n operation, but not all slicing operations are big O of n. For example, if you take L of 1 to 3, that is not an O of n operation.
Correct.
So this difference I did not understand.
Okay, I think Ankur only posted this same example. So Ankur, do you want me to continue?
Yeah. So in generally we say that slicing is an order n operation, right? And n is the slice, the size of the slice. Okay, not the size of the list.
Okay.
So suppose you have a list of 10 elements and you want to slice it into half. Just take the second half. So 5 elements will be copied in a new object, right? So
yes.
Copying 5 elements is an order of 5 operation. It will take 5 steps.
Okay.
In that sense, it is an order n operation. You got it? But if you are giving constant values always, just copy first and second element, whatever be the size of list, it will only copy 2 elements, right? So in general, if you are using variables, if you are using just half of the size, right, then it will become an order n operation, because the size of the list, as the size of the list will grow, half of the size of the list will also grow similarly.
Okay.
But if you want to copy only the first 2 elements, whatever be the size of list, if it grows to 10 lakh or it grows to 20 lakh, you have to copy only 2 elements.
Okay, now I got it. So if the prefix or suffix of the colon in slicing is missing, that usually takes O of n, size of the full
It's
list.
not just about missing. If you say last, if you take both variables and not constants just, then it could, then also it could be a order and operation. Suppose you say slice from first to last. There are two variables. So whatever, anything first and last, values of first and last could be anything, right? In that way, if the values of first and last is fixed, first is 0 and last is 1. Okay, so it depends on the scenario how you are using it. But in general, you can pass anything. That's why it is an order and operation. It's not fixed that you can only. So suppose if you want to read one element, L of I, okay, reading one element, L of I. So this will not be order and operation, because you here for I you can pass only one variable, one value, either 0, 1, 2, anything till n minus 1, and n is the size of the list. So you can pass only one value. So this will always be a constant operation, constant time operation.
Okay.
Right?
Yes, sir.
So in general, we will always say that slicing is an order and operation, but don't get confused if you don't use it in the way, if you just use it to extract only two elements.
Cherian, look at like this. If the slicing mechanism, what is there in Python, right? That square bracket and colon thing. If I tell you that that's not allowed anymore, it doesn't exist in Python. And if I give you a list of, let's say, 100 elements, and I ask you to create a slice of second half from that list. So that means your input is, let's say, A, which has 100 elements, and you are supposed to return me another list B, where I have elements which are the last 50 elements from that list. What you will do?
Maybe a for loop.
Correct. You will write a for loop which will run
from 50 to 100.
From half to length minus 1. Correct?
Yes, yes.
Correct. That means what is happening in this case, your loop will run for total size of array divided by 2.
Yes.
Correct. So this time your input size list was 100. What if I make it 1000?
Yeah, it will run 500 times.
So, but it will always be half of your length. Correct? Length can be anything. There is no restriction on that, right? And in keeping that in mind, we say it's order n, because this time I said, okay, fine, I want only last half. But what if I tell you I want all elements except first one? Like what we have done in CT, if you remember those init and rest of, functions from computational thinking. You remember those?
Yes.
So what if I asked you to create something like that? You will run a loop from first index to n-1 index, right?
Correct.
Correct. So in that sense, it is always order n, provided what's your requirement for the slice. Or on the contrary, as Ankur mentioned in the example, or even now, I can give that index saying I want elements only from first index to third index. Then I don't care, right? What is the size of that list? It can be 1 million, 1 billion, or 100 billions. Doesn't matter. I want only one colon 2, 1 colon 3 in that case. So your loop, your same for loop will execute only twice, right? Doesn't matter what your size of list is.
Yes, yes. Now I got it.
Yeah,
thank you.
So it depends on your use of it.
But even then, if you use it as first two elements, you will say it is an order and operation only in general.
Yeah.
Okay.
Okay.
Because your n is, this time your n is 2.
Yeah.
Thank you, sir. That's all I had.
Yeah.
Okay then. So, okay.
Yeah, that's fine.
I will leave. Yeah.
Yeah, sure.
Yeah.
Okay.
Bye, everybody.
Yeah. Bye. Thanks, Ankur. Okay. Cherian, we thought it is something which is more critical or something which is specifically happened on discourse, and that's why we thought let Ankur be also there, because original discussion started with him. Okay. It was just normal doubts. Okay. Yeah, Cherian. Anything else? That's all right.
Nothing else. Ankur came just for that.
Yeah, actually, I mean, I mean, none of us were there in yesterday's live session. What the feedback we got from Rajat is you wanted to discuss something very specific with Ankur. So we thought he said something wrong on discourse or something incorrect on discourse, and then that arise. I mean, that led to some confusion. That's what we thought. That's why we thought it's better if he is also here. Yeah.
Anyway, thanks a lot. Thanks a lot.
Yeah, sure. Thanks. No issues. All right. So we'll go back to original order. Yeah, Shreya.
Yes, sir. Hi, good afternoon.
Yeah, hi. Sorry you had to wait a long for a
No
long
worries,
time. Yeah.
no problem.
Yeah,
So I had a few more questions on hashing. Maybe some of it is theoretical, I'm not sure.
Yeah, please go on.
The first thing is
But you were there when I was explaining it to
Yeah, I was there. I listened to that entire thing. Maybe a little more on the applications or how it works. Like, is hashing a predefined function for any process? Like in the lecture, sir has given us an example of uploading files onto cloud. So that cloud interface will already have a predefined hash function, is it? Is that right? Or will it?
Yeah, please go on. Yeah, please
so,
continue.
or will it create a hash function every time a file is uploaded?
Okay. See, it's not that straightforward or that's crystal clear with respect to such huge applications.
Okay.
So, but I will tell you, the hash functions are predefined. Okay, because the reason is, unless you implement same hash function for all values, it will not make any sense, right?
Right. Yeah.
Right. So same hash function has to be implemented across all values, at least within that set, right? Maybe for if you have different storage spaces, you can have different ones for different storage spaces and so on. But ideally, it should be same, right? So it's not computed runtime. At least hash function is not designed at runtime. Of course, hash value is computed runtime. So it is, see, consider this as the principle behind, I mean, you might remember this example. You remember bucketing from computational thinking?
Not.
We had those cards, we divided those cards in buckets to simplify the processing.
Got it. Yeah, correct.
What is that bucketing is? We implemented some hash function over it and divided data to simplify our processing.
Okay, got
it.
Yeah.
That we implemented same. I mean, it was actually a hash function only. But of course, at that time, we would have said that it would have made your life even more difficult, right?
Yeah.
But ultimately, that's exactly what we are doing.
Okay. So then if I input the same input at different runtimes, I will get different hash values?
No, right? If you are implementing, if you are executing same hash function on same value, the value will always be same, right?
Okay, there's another follow-up question there. So suppose there is a collision in the data which I'm uploading.
Correct.
So now this collision, like the what do we call open addressing or closed hashing, does it get invoked at runtime again, or is that something that is again included in the hash function modality itself?
Okay, so that modality is also available. So it's simply like, okay, first try with this hash function. If it works, it works. If there is a collision, there is a secondary, okay, like a backup plan kind of thing is already predefined.
Okay. So that will ensure that it doesn't, the output hash doesn't differ for the same input, because I already have a predefined closed hashing which is there.
Correct. So irrespective of whether it's which type of collision resolution mechanism you use, it is already defined. It can be either of two, what you just mentioned or what sir has explained. It can be either of those, but it's already defined that, okay, if first thing I will try this, it fails, this is my backup plan. If that also fails, then this is the backup of backup and so on. So that's already defined.
Okay, got it. Then
I mean, that's the job of person who designs the first level of hashing, should also make sure that, if it fails, there has to be some secondary mechanism which will take care of it. It's just like if else, right? If else, fails, you should only write that else block, right?
Exactly. Yeah.
Same thing.
Okay, so what is the benefit of a closed hashing? I mean, what I'm comparing it to is, suppose I have an input of n size where there are, or let's say this is a very, very simplistic example of size 50, where I have, let's say like 10 collisions. So then is it because like I need to redo the closed hashing exercise, right? Like the whole allocation into the array, I need to redo the whole thing. So why is it preferred over creating a new array itself? Like I'm not able to explain it exactly, but what I'm trying to say is like, why don't I create a hash function which makes it one-to-one rather than using the existing hash function and then doing the closed hashing again, which is a second exercise, right?
Okay. Okay, so you are saying, why don't we design such hash function where collision will not occur?
No, I'm saying that based on the data, like,
okay.
Let's say I have a hash function generated for 100 inputs out of like 10,000 different inputs mapped to 100 inputs, right?
Okay.
So now I have a data set, which is, let's say, of some 50 inputs. Now,
Okay.
why don't I create a new function for the 50 inputs itself with an array of 50 rather than trying to fit it into the existing 100 where collisions may occur and I need to redo the closed hashing?
Okay. The point is, see, whenever these systems are designed, that time what data is gonna come, that we cannot predict that, right?
Okay. Yeah. Yeah.
Of course, I mean, as the sir, I mean, let's take that same example of cloud. The cloud developer must have implemented something, but they cannot predict that what's gonna get stored over here.
Okay. Okay.
How can you predict that? I mean, of course, there are some variety of range of, okay, these things are possible, but ultimately exactly what comes in what form, in what size, in what order, that's not at all predictable, right? I'm not saying it's applicable everywhere. At some places it is predictable, but most of the places we cannot predict it when it comes to any kind of storage.
So what I can say is that the job of someone who develops this is to sort of anticipate what are the possible kinds of data and then build a hashing function to accommodate all of them. If there are collisions, then there is a backup plan which is available. Is that
correct?
Right?
Correct. See, so your hashing function has to be designed in such a way so that there is very minimum level, minimum amounts of collisions. That's the best hash function. If you have minimum amounts of collisions, correct?
Yeah.
But there is a disadvantage of doing that. What is minimum collisions? When you will get minimum collisions, when you increase the size of your output of hash function, right?
Yeah.
Which that again that compromises your access speed.
Right. Yeah. Correct.
So it's just a handoff between both.
Got it.
So
and yeah.
So as you have to decide the perfect balance between these two based on your requirement.
Got it.
Yeah.
Okay. And the other thing is, why does a hash function always have a fixed output? As in the example which I gave you, right? Like 100 is the output size which I have. Now, like, let us say I have an input data of 50. So what happens to the remaining 50? Like, what happens to that in the output? Like, there is nothing to map, right? So how do I give these remaining 50 output?
Okay. So you are saying that in hash table there will be a places where it will be vacant, right?
Correct.
So they will stay vacant unless something comes and which gets mapped there, they will stay vacant. So it's just like a list, right? If you create a list of, let's say, 100 size, and ultimately if you use only 5 out of them, 95 will stay empty over there, but that address will be available. It may not be used, but it will be available. It will store, maybe like in Python we have that none, right?
Yeah.
So something like that. I mean, operating system doesn't have the concept of none, but as per that particular implementation, it will store some dummy value over there. I mean, some non-existing. I mean, just generally it's referred as null.
Okay, I understood the storage part. Like, I think what is a confusion is the output part. Like is the output of a hash function given for a collective input, or is it given for each character of an input? It should be typically collective, right?
Okay. So that hash table exists there, right?
Yeah.
As you explained, I mean, as you said, you understood the storage part, but if I have to extract the output from there, I can extract it in either way. Either I can ask for the entire thing along with these empty things, or I can get only those things where actual values are there, which is meaningful information for me.
Okay, so in the
Either
second
is
case,
either is possible, and that's the actual difference between your adjacency matrix and adjacency list, right?
I didn't get that connection.
That is the difference between adjacency matrix, where even though there are zeros, you get
Okay,
all those.
okay.
Whereas the adjacency list, you get only what is actually there. I mean,
Got
only
it.
the meaningful values. You can get it. I mean, it depends again on how you're storing it. You are either storing it as a matrix, then you will get all. If you are storing it as a kind of adjacency list, you will get only meaningful ones.
Got it. So,
Yeah.
so in the second approach, then for each input, the hashing, the output of the hash function can be different. It need not be the same length.
Yeah, correct. Agree.
Okay. And so one last question is, I think like generally when I was reading about hashing is that like it is an algorithm which is used in case of passwords and all of that. I'm not too sure about the details, but my question is, why is this not reversible? Because each input is mapped to like multiple inputs can be mapped to like one output, right? So if I have an output, why can't I go back to what my input was?
Yeah, you can. See, the thing is, if you go over internet and look for hashing, you will get tons of resources, right? Because over here we introduce hashing only with respect to dictionary, because that is how it is internally implemented. Beyond that, there is a completely different domain which is based on this. This funda of hashing. Okay. This you must have heard about. Anything which is related to security, use hashing.
Yeah.
Let me put it at that abstract level. Anything where computer level or any digital security comes, there is a hashing.
Okay.
Okay.
Yeah, I guess Bitcoins also use a hashing mechanism, right?
Not just Bitcoin. Anything where digital security comes into picture, there is hashing.
Okay.
What do you think? I mean, you have a Google account, you have a password.
Yeah.
What do you think? The Google servers are storing that as a plain text? No. Your password gets stored as a hash of it, so that no one, even the person who has access to that database, will not be able to extract that password. I mean, of course, there are hacking attacks and there is leaks and all. That's a different story. But in a ideal scenario, that's how it is. That's why it is. It's the correct term for it is encrypted. You must have heard it many times, right?
Yeah.
As you can see, even nowadays, even WhatsApp messages are encrypted.
Yeah.
Right. So this is what that encryption means. What encryption means? Hashing only, nothing else.
Got it.
Only thing is there are n number of such encryption algorithms, which do this hashing principle only. And as you said, it is reversible, and that's why for every encryption algorithm there is a decryption algorithm.
Right.
Okay, so of course, I mean, it's a simple mathematical equation, right? Nothing beyond that.
Yeah.
Of course, actual algorithms will not have equations which are as straightforward as that. They are slightly more complicated, but it's just a mathematical computation, nothing else. So you can always do reverse engineering and go back to original answer, and that's what you do. That's what actually happens also.
Got it.
Yeah.
Okay. Yeah. So I just had one question on the previous graded assignment also. Is that something I can ask here, or it's not been raised in discourse?
Which week? Week 1 or
week 2.
Yeah, please go on. It's already closed. So.
Question number 6, like it's the question which says a program is written in 3 stages, where the first stage is big O of n log n.
Okay, hold on. This is normal graded, not a programming, right?
Yeah, it's the graded
assignment. Yeah. Okay, just hold on. Yeah. Do you remember question number?
Question number 6.
Okay. Yes. Yeah, go on.
Yeah. So here the doubt I had was the second stage is of which is based on the result of the first stage. So does this mean that this is big O of 1 or big O of n? Because if the first stage runs completely and gives a result, the result will just be 1, right? Which will become the input for the second stage. Is that how it is to be interpreted? Or
Okay. Let me just go through it. Okay. What it says, a program is written in 3 stages. So in general, major programs can be divided into 3 blocks. So most probably there are 3 such loops or something like that, right?
Yeah.
The first stage is of big of n log n. So there is some mostly loops which run for n log n. Then second stage for n square, which is based on the result of first stage. Okay. I will come to that result part. Then what it says, the third stage is big O of n. What will be the asymptotic complexity of the entire program? Okay. The thing is, what it says, the second stage, which is big O of n square, which is based on the result of first stage.
Yeah.
Which means there is some computation happening at first stage, and there is output of it.
Yeah.
And that output is considered as an input for second stage. Correct. So for example, you're doing some sorting at first stage and second stage, you're doing simply printing the sorted values. So you cannot do that second stage unless first stage is executed. Somewhat that's what it says.
Yeah.
Okay. So your n log n should happen first, then it should execute n square.
Yeah.
And then maybe n is maybe it's not mentioned. It might be dependent or independent.
Correct.
But so our final question is, what is the total asymptotic complexity of the program?
Right.
So if you consider it like if you form a equation out of it, it becomes n log n plus n square plus n.
Okay.
Correct. But ultimately we take the highest power of the term with highest power. Correct.
Yeah.
So we end up taking it to be n square, and that's why the complexity of entire this given program is a big O of n square.
Okay, I think my confusion still is that based on the result of the first stage part, because if I consider the result of the first stage as 1, because typically the output would be like one single, either a list or an element.
Not necessary, right? Output can be anything. Or as you said, output can be a list, right? A list will have a size, it can be of any size, right?
Okay.
When you say output cannot always be a single value, right? It can be even a huge list.
Okay.
Output can be anything. That depends on what exactly you are doing in that n log n computation.
Okay. And when we say stages here, these are 3 independent stages, like not necessarily like a loop within a loop.
Not necessarily. That's why we have not given actual code, right? For example, correct. There is one more question was there. Okay, look at this particular code.
Yeah.
Okay.
Yeah.
So if I can consider, okay, this is just one level. All these are, big of one computations, right? Just a single instruction. Consider this loop, which runs from line number 11 to 70.
Yeah.
This is first stage you can consider, and it will have some complexity, right?
Yeah.
What that complexity, I mean, that's not what my point is here. Then there is second loop which runs from 19 to 21. This you can consider second stage, it will have some complexity.
Yeah.
And then this is third loop will have some complexity. And ultimately some question is based on what is the complexity of entire code. That's what that question is. But here actual code is given. There you have directly given the asymptotic complexities of each block, independent block.
Yeah. Okay, sir. Sure. Got it.
Yeah.
Thank you.
Okay. Thanks. Okay. Now going back to next person. Yes, Sandeep.
Hi, good afternoon, sir.
Yeah, hi, good afternoon.
So I had a couple of doubts.
Yeah.
The first doubt is in the lectures, professor told us that the Python list is implemented using a data structure called array.
Correct.
And apparently array only lets us use same data type for all its elements. It doesn't allow us to use heterogeneous data types for elements. But we have seen in Python that we can store many different data types in a single list. So how is that implemented if the intrinsic data structure is array?
Okay. So that's the point, right? You're considering arrays with respect to a specific programming language. I believe you have studied some other programming languages, right? Where this concept is there, where same data types can be stored in arrays.
So even in numpy arrays, we are only allowed to use the same kind of data for all its elements.
Correct. So that's what I'm saying, right? That is another reason Python never calls it array. It calls it list only. Correct. In list, is it allowed? It's allowed, right? To have multiple data type values stored together.
Yes, sir.
Right. And that is, see, otherwise, why you think Python developers call it list? They would have also called it array only, right?
Yes, sir.
It's called list because even, see, as a user of Python language, our perspective for our use, what it is exactly like linked list. It is exactly like list. We can use multiple different data types, values of different data types together. We have this flexibility also available to us. All these operations can be performed in certain ways. So all those, that appearance to us is like a list. Only internally they have implemented using arrays. Correct?
Yes.
How they do it, I mean, of course, I mean, I am not one of the developers of Python, but there are various possibilities through which you can actually do it. Okay.
Okay, sir.
One such example, but before that, can you tell me, have you, sorry for that. Have you studied any other programming language, so that maybe I will be able to put it in that way? Maybe a C or any C++ or Java or anything like that?
No, sir.
No, right? Okay, fine. But you remember that object-oriented programming concepts, what we have even studied in Python, right?
Yes, sir.
So what is object in general?
Object is a collection of object.
Object is a collection of, I mean, inside object, there will be multiple values. It can store multiple variables of different types together, right? That's generally, I mean, it's not an accurate definition, but that is possible with objects, right?
Yes, and a collection of methods that we are allowed to perform on those objects. It's a collection of that.
Yeah, it's collection of but in this sense, we don't want methods. I'm focusing only on that variables part. So similarly, internally, what Python, every collection in Python is an object ultimately, right? Whenever you create, let's say L is equal to square bracket, and check the type of L, it says object list object, right? A type object, and then it will say, I don't remember exactly what it says. It prints type list, and it's of object type, right?
Yes, sir.
So the thing is, every variable, no matter whether it's an integer, whether it's a list, it's a dictionary or anything, in Python, everything is an object.
Right.
Okay. And because it is an object, even though it might internally implement, the implementation is as array, it allows you to store values of different data types. And that is why I ask you whether you have studied any other programming language, because if you go to some programming languages like C or something, over there, the concept of object doesn't exist. Over there, this integer or a string has a different meaning. But in Python, everything is an object. And because of that, this is allowed only here. It will not be allowed anywhere else where pure arrays are used, because over there, arrays are actual arrays. But here, array, or in this case list, is actually an object only. In Python, everything is object. Even though you say a is equal to 5, a is what? Actually integer, right?
Yes, sir.
But actually it's an object of integer, or there is a class internally, integer class, and that integer class has an object which is used, which is referenced by that variable a. So that's how the internal implementation is there for any object-oriented programming. I mean, most probably next semester you will, I mean, depending on you, but from our side, we are going to provide you Java language for next term, right? Over there also, it's again object-oriented programming language. Over there also same thing. Integer, float, string, all these are actually classes internally. So whenever you create any variable of that data type, right, it is actually you create an object of that class. It may not appear that way, but internally that's how it works. And because it's an object, that's why all these things are allowed.
Thank you, sir.
Yeah.
I have another doubt regarding the hash function.
Okay. I think
Suppose
today's popular topic is hashing, huh?
Yeah, sir. It's very
Yeah.
interesting.
Yeah, sure.
Suppose I have a key for which I calculated the hash function, and once I calculated the hash function, I go and check that index is already filled with another key.
Correct.
So
that's
I use
collision. Okay.
that. I have to use an open addressing and put that key into another location. Suppose afterwards that other key which was in the original location got deleted, and
correct.
that location becomes empty.
Correct.
After that, I search for the key which I place somewhere else now. Then this function will again get calculated, and it will point towards that empty location and see that it's an empty location. I might say that no, the key is not there in the dictionary. So how is that problem tackled?
Okay. So the point is, delete is not that straightforward operation. Okay. It may appear that, okay, there is something, you simply removed it. It's not the case. Every time, I mean, irrespective of your hashing or anywhere, whenever you delete, there is a vacant space, right?
Yes, sir.
As you mentioned, even in this case. So always there is some mechanism implemented which decides what to do with that vacant space. Okay, you can't leave it vacant for indefinite amount of time. Then otherwise you will run out of your memory, right? So yes, that has to be reused for some reasons, for some purpose. So with respect to hashing, again, as I was mentioning earlier, it completely depends on how the delete operation is implemented in this case. I mean, there can be many ways it is implemented, but the thing is that's the the point is, whenever you do this delete operation, some rework should happen with respect to remaining elements as well. I'm not saying their locations will change all the time, but some rework or recomputation is required all the time when there is a delete operation. For example, even with arrays, right? If we delete some element from in between, all other things has to be moved one step towards left, right? So yes, similar thing. If wherever there is a delete operation, many times it is considered as one of the very costly operations, of course, depending on implementation, but it is also costly as many times like insertion, and if not more, because of this extra work which is required in order to avoid the same issue which you mentioned. Okay, so Sandeep, before going into next step of this explanation, can you tell me if the value is there, whatever you said, right? Value is not deleted and value is there, then what will happen? I mean, in the ideal scenario, no delete, nothing. I mean, there is a collision, so I put my value at some other location, and now I'm trying to access that value. How it will work?
First, it will compute the hash function and first go into the first location.
Correct.
See that despite the hash function output is being the same, the input values are different. It's a different thing. So it will again go, open addressing will allow it to go to the next possible location where that item could have been stored.
Correct.
So in a way, it would probe different possible locations where that item has been stored, and ultimately either it will find the item or it will come up with the answer that the item is not there in the dictionary.
Correct. So how it came to know that at this location whatever I'm looking is not there? Because of collision, it has been put somewhere else, because the value currently available there is not what you are looking for. That will trigger that, that will indicate that, okay, there is some collision happened earlier and now I should look somewhere else. That's what it will tell you, right?
Yes.
Because you found the value and it was not what you were looking for, correct?
Yes, the location is occupied, but with a different key, not the key.
Correct, yes. Correct. So in same mechanism, implement on the contrary part where the key doesn't exist. I mean, it's deleted, as you mentioned. So in such case, one easiest mechanism is to keep a flag over there. I understand. I hope you understand what flag is, right?
Yes. Okay. Instead of keeping it null, I'll have to keep a flag.
Maybe keep. I mean, see, I'm not saying this is the exact implementation which Python has. I'm just saying it's one of many different solutions, right?
Okay.
You can keep a flag which will tell you, okay, I mean, along with that matching value, you can check whether flag is, okay, I will have flag deleted, true or false. If the flag deleted is true, I will not bother. I will start looking at other places. Easy, one easy mechanism, right? Which will not have that much overhead as well. I mean, it will not increase the complexity as well, correct? Because just one comparison.
Yeah, so that, sir, this will distinguish it from a location which is null, which is empty.
Correct. So location being empty can be for multiple reasons, right? Either it's not used at all, or it was used previously and now it's been deleted.
Yeah, exactly.
Right. So maybe initially I can keep the deleted flag to be false. Whenever I delete, I make it true. But there is a possibility that that location, some new element comes, then maybe I can reuse that location and make flag back to false.
Yes, sir. I understood.
Right. So this is one mechanism. I'm not saying that's the only mechanism or that's the mechanism which is implemented, or you can put some extra overhead. And if there is a collision, right, then that item is stored somewhere else. You maybe bring that item back to this vacant space. That's also a possibility, right?
Yes, sir.
But of course, in that case, there is a much larger overhead, because every time there is a delete operation, you have to remember what all previous collisions happened because of that location. Then what is the new location of that element, and bring it back to its deserved location, and so on. So that puts additional overhead. But then searching becomes, then the next time access becomes faster.
Okay.
You got my point, right?
Yeah, absolutely, sir. Thank you.
Yeah, so it depends on how it is implemented. Okay, so yeah, that's it, right, Sandeep?
Yeah, sir, that will be all. Thank you so much, sir.
Okay, thank you. Next is Laksh. Laksh or Lakshay? I hope I'm
yes,
not.
Sir. Good afternoon, sir. Lakshay, sir. It's Laksh.
Laksh. Okay, hi, Laksh.
Yeah, good evening, sir. Actually, sir, I have some problem in lecture 6 of week 3. There, sir, expressed about class node and
hold on. Can you just repeat so that I can try to check what lecture you're talking about, right? Week 3, lecture number
6, sir. 6.
Okay, designing a flexible list and operations on the same, right?
Yes, sir.
Okay, yeah. Go
on. In this, sir talked about nodes and how a list is interconnected, and there have been graded questions, and GRP 3 is also about it, the class node. Sir, I understood the implementation mechanism of the class node, but I'm not able to implement it by myself. So it would be very helpful if you could solve practice assignment question number 1, which is about the this class node only.
Okay. So I can, but the point is, see, we have decided a strategy, and I'm really sorry, but cannot deviate from that. The point is, practice assignment has to be solved from students, then only you will get practice. If you have to give ready-made answer, we could have released solutions along with them, right? And that is the reason we don't release practice programming assignment solutions on same day. You will get that solution, but on this Friday. For previous weeks, last Friday we released week 3 without solutions. Solutions we will release this time along with week 4 content. That's the decided strategy, and we want students to try for 1 week. You put your 100% effort, so if not 100%, more than 100%, and get that solution. If not, then ready-made solution is available, but giving ready-made solution will not help, right?
Okay, sir, that's fine. But can you just give me some way how to approach that question particularly?
Yeah, that I will do. So that's what I was going to say next. I will give you hints, but I cannot give you direct solution.
Yes, sir. Hints would work for me. Yes, sir.
That should come from you. This is related to PPA 2, right?
No, sir. No, sir. Practice assignment 1. The objective one, sir.
Oh, okay. Sorry. Yeah. Okay. So, I mean, the answers are already visible, right? For this one also, the answer will be there, right? I mean,
yes,
check
sir,
answer is always
answers are visible. Yes, sir.
Correct. So that I mean, I just wanted to show that is there. Okay. So your question is with this particular node class, right?
Yes, sir. Yes, sir.
Okay. So the point is, what is happening in this particular question? I mean, what this question is all about? Have you understood? It's about linked list, right?
Yes, sir. And we have to delete the middlemost element, sir.
Correct. And when we say linked list, every element in linked list is generally called as node. Correct?
Yes, sir.
And every node has two. I mean, node is a class, and in that node there are two entities. I mean, you must have seen that visual or graphical representation of linked list in the slides which sir used in lecture.
Yes, sir. Yes, sir.
Right. Looks like a small square box which is divided. It's a rectangle divided into two fields. One
yes,
field
sir,
is
upper and lower.
No. Well, left and right that's how usually it's done. The one field is called value and the next field is called the
next.
pointer to the next. Yeah, that next.
Yes, sir. And the last one, and there is the value is none.
None, correct. So, okay, let me get that first and then maybe I will come back to this code. Okay, so can I change? Can you see this slides?
Yes, sir.
So what this V0 is? V0 is a one object of that class node.
Okay, sir.
Okay.
Yes,
what all entities are there in this object? V0 is the value, and this this big solid
pointer
circle
also
pointing that this like a pointer. This is that next indicator. So what next will store? Next will store the address of V1.
Okay, sir.
And so on, right? So this rectangular box you see over here, right? This V1 along with this dot, this V1 with this pointer, so on. Each such box is one object of that class node.
Yes, sir.
Okay. That is the idea behind, I mean, this particular, this is a graphical structure, right? You cannot store this in Python program.
Yes, sir. Yes, sir.
You should convert this into some collection, some variables, then only a programming language will be able to understand it.
Yes, sir.
But this time one entity has two subfields. Correct?
Yes, sir. Yes, sir.
And because of that, we created an object of it. And that one object has those two subfields. That is what it is. Correct?
Yes, sir. Yes,
now
sir.
let me go back to that class, that particular node class. So that is what that node class is. Okay. Which is implemented using two different fields, value and next. Value will store the actual value in that the square box, I mean the rectangle what I showed you, right?
Yes, sir. Yes, sir.
Over there it was V0, V1, V2, V3 up to Vn minus 1.
Yes, sir.
That is this value field.
Yes, sir. Understood.
Okay.
Yes,
and
sir.
then the next field is initially none, because I mean by default it's none. Every time we set a value, we set it to true, saying that there exists something after that.
Yes, sir. Okay.
Okay, so if this is this particular node object which I just created, if it's not the last one, okay, if it is not the last one, then I will keep its next its next to be some other value, or else that next will remain to be none.
Yes, sir. Yes, sir. Okay.
Correct. And what this isEmpty is doing? IsEmpty is just checking whether this particular
node is empty or not.
Structure, yeah, it is empty or not.
Yes, sir. Yes, sir. That I understood.
So that's the see, this class is nothing but what you see visually in the slides. This is the translation of that graphical representation into Python logic.
Yes, sir.
It's nothing other than that. It's as simple as that. So every time, I mean, these methods, right? This delete middle is it's the method, right?
Yes, sir.
The function. So whenever this function gets called, we are passing some parameters, so let's say image. So it's some parameter to it called head.
Yes, sir.
So consider head is always going to be object of this class.
Okay, sir. Okay.
Because of that, head, now your current CURR is equal to head. So we just assign head to current. Okay.
Yes,
so
sir.
Current of next. What is current of next?
Pointing to the next node.
So this next came from here because
yes, sir.
Current is a pointer which is allotted to head, and head is the object of this class.
Yes, sir.
If I don't give you this class, how you will know what is dot next mean?
I won't know that.
You will not know, right? That's
Yes,
why
sir.
this class definition is provided to you, just
Yes,
to
sir.
tell you what the actual this dot next means.
Yes, sir. Got it.
Yeah. Beyond that, now it's your job.
Yes, sir. Sure, sure.
Yeah.
I will figure it.
Yeah.
Thank you
sure.
so much, sir.
Yeah. Thanks. Okay. Next is Mihir.
Hello.
Omkar, yeah, hi Mihir. Yes, Mihir.
So, sir, my doubt was not regarding any academic week 3, but regarding the programming portal in our dashboard.
Okay.
Yes, sir, I wanted to ask, sir, after the week deadlines are over and all the scores are calculated. So, sir, after that, can the programming portals be opened so that we can tinker with the code and test a little bit more?
Practice questions you can, graded you can't.
Okay, yeah, sir. So I was just checking the practice assignment for week 2. So right now it's locked only. I cannot test my code in that. So.
Oh, really? Just hold on. Let me see. Ideally, it should not be. For practice assignment, should be open. Let me see. Hold on. Due date. Okay. This should not be the case for practice programming. It should have been kept open. Let me get it open. Okay.
Okay. Thank you, sir.
Yeah.
And
for practice, I make sure that I don't know if them the people, I mean the portal team who configured it might have made a mistake, or let me figure out why that happened. But practice should be open, and I will make sure that it's open in few minutes. I will get it open after the session. Okay. For graded, that's not possible because you can always submit it again, and their scoring system will be a problem.
Okay. Thank you, sir. So, but sir, I have seen that. So right now, the graded assignment solutions for week 1 and week 2 haven't been released, right?
No, they are there. I mean, you go to that question, you will be able to see the solution.
Okay. Yeah. Okay,
thank
you, sir. And
I mean, we did not release separate PDF because it's already available over there, right?
Okay. Yeah, sir. I did not check that actually.
Yeah.
So, and sir, for the graded, I understand the system has to save the code for future reference and all that. But
correct.
Sir, can you suggest a way for that so that we can somehow import the test cases and then test in Replit or something like that?
You can copy it from there, right? It's easily, you can easily copy paste. I mean, yeah, it's a manual labor, I can understand, but you can copy paste from there and execute it elsewhere.
Yeah, sir, I was doing that, but actually in some cases the lists are very long, right?
Okay. So see, we can provide you it in terms of Python, in terms of PDF or something, but again you will always have to copy paste it, right? We cannot reconfigure same question on Replit and give it to you, right?
Yeah.
That's not possible, right? So somewhere that copy paste operation you have to do either from portal, or if you want, I can arrange a PDF for you. But I mean, for you as in for everyone, but still that copy paste operation has to be, it has to be that manual, that labor has to go in, right?
Yeah, but sir, if a PDF is provided, it will be more easier to copy, right? Because the window is a little bit small in this portal for long lists.
Okay, sure. So if you, I mean, if that's the thing, that is just the because of difference between portal and PDF, I'm sure. I mean, we can release PDFs. That's not a problem.
Yeah, sir. Actually, the mouse, our mouse can shift a little bit faster if the whole list is visible, right?
All right, fine. It's fine. I understand. So we'll get you PDFs. Okay.
Okay. Thank you, sir. So will the PDF be like a solution format only, or will it be like test case PDF?
It will have actual question. It will have suffix code. It will have suffix prefix code. I'm not sure. For few questions we might give it. For few questions we may not, because that sometimes reveals the mechanism which we implement internally. So I'm not sure. I mean, I cannot give you guarantee about prefix and suffix code, but the PDF will have question statement. It will have public, private test cases and solution.
Yes, sir. That
this much I can give you guarantee. Regarding prefix and suffix code, if it was visible, I mean, sometimes you will see, right? Prefix and suffix code is sometimes visible, but sometimes it's hidden also, right?
Yeah, sir.
So if it's visible, I can give it to you, but if it's hidden, then I can't give it to you.
Okay, sir. But actually, in just if the test case is provided, I think in most of the cases we will be able to test, right?
Yeah. So that's what, right? I mean, I'm not just giving you test cases. I'm giving you more than just test cases, right? Yeah. So I will give you, but that may not happen immediately after this session. That might take some more time. But that practice questions, I will get it open immediately after this live session.
Yes, sir. And if you have some another suggestion of how we can like test the code test the graded questions after the deadline,
okay,
you can tell us, sir.
Yeah. So see, the thing is, this testing after deadline has to happen outside portal. There is no doubt about it, because as I said, right, once your final scores are closed, as they are closed, we cannot open that. I mean, that's how the application or the website has been developed. So that cannot be changed. So it has to happen elsewhere.
Yes,
so elsewhere, I mean, that's up to you. You can use any platform to execute the code. Either it's a Replit or Google Colab or Jupyter Notebook or whatever Python IDE you prefer. But as I said, right, if you are using it somewhere else, then you have to configure it. The test cases, you have to configure it yourself and do it manually. I mean, we can't configure it again somewhere else, right?
Yes, sir. And
that's not possible.
In the future, if we have to work with some like .csv files or something like that, so that you will think of a way to provide that also, right?
In this course, in PDSA course, you will not. I mean, I know all lectures and I know what's gonna come in all remaining assignments. So there will not be any CSV files or inputs from files.
Okay. Thank you, sir.
Yeah, at least for PDSA, I can assure you of that.
Yeah, sir. And sir, and just reminder to unlock that PPA.
Yes. Immediately after this live session, I will get it unlocked. For all practice programming questions, I will get it done.
Okay. Thank you, sir.
Yeah, sure. Okay. Anything else?
Hello, sir.
Yeah, hi. Yeah,
so I had a very simple question. So I wanted to ask, what kind of approach should we have in solving the GRPAs?
Okay.
So the first, my specific, actually it happened only in week 1 GRPA 1 for me. As in such, I was trying to solve the code using only pure logic, so without importing any standard libraries and stuff. But I just couldn't do it in like 4 to 5 hours. Then I decided like, okay, let's go. There is a standard library. I imported it and used it, and it makes made it very much easier. Like almost all the effort was gone. So are we encouraged to do that, or
which library you use? Which library?
tools.
Which one?
ITER tools.
Okay. Okay, then let me tell you, I mean, there is nothing wrong or there is no harm in using such libraries. But whenever we design these questions, right, we don't anticipate students to use, even to know these libraries, okay? Because formally we have never covered any of these libraries. So at least in PDSA course, we do not expect you to do it. But if you do it, then we will not stop you, because that is absolutely fine. But ideally, whatever you are expected to do, you should be able to do it with pure logic. Okay. I mean, of course, as you said, libraries will make your life easier. But what I'm trying to say is, even without libraries, there exists a solution, and it might be slightly complicated or may require more efforts, but it exists. It's not like it's not at all possible to solve that problem without library. That's not the case. Okay, later on that might happen, because numpy might become it will become a necessity, because as you must have seen, I mean, you have seen only week 3, but from week 3 onwards you will see almost every lecture prof will use numpy. And if in that case, as we go ahead with various different types of graphs or things related to graphs, numpy becomes a necessity. It's not mandatory, but it's a privilege to have. And in that case, we will expect you to use numpy. Okay. That's already available, so you can import it and it will not give you error. So actually, otherwise numpy would have given you error, because it's external library, right? But we have added it, and now even though if you would have tried importing numpy in week 1, it would have given you error. But now if you go and try to import numpy, it will not give you error, because we have made it, I mean, we have enabled it for all students. So keeping that, I mean, in that sense, yes, you can use libraries, but it's not mandatory to use. We expect you to write a logic without libraries, because that will improve your core thinking or core logic. Okay.
Okay, sir.
Yeah. See, if you can do something without libraries, then later on doing it without libraries is easy, right?
Yeah.
But if you do it other way around, then you will not learn, you will not learn it, the whole picture of it. You may learn only the small portion of it. And then maybe you will panic if library access is removed for you. Because there are many places, when you give tests, or maybe I'm not saying all, but there are some competitive coding platforms or many places where you go for this interviews, right? I mean, I should not say word interview, for this for hiring process, where there is a programming test. Some places they will not allow you to use libraries. Then there will be a problem. Okay, so keeping a larger picture in mind, I will say you better try it without libraries, with pure logic, so that if library is there, then it will become easier. Okay, it will not become tougher. So as they say, prepare for worst and hope for best. So
yes, sir. Okay, thank you.
Yeah, thanks. But numpy, definitely don't avoid that. From week 3 onwards, where it is a graph, go ahead directly and use numpy. Don't try to implement list of list or a dictionary of dictionaries. Don't do that complicated stuff. Please, I mean, I will insist, use numpy. At least for that purpose. Remaining, it's your choice.
Okay, sir. Thank you. Got it.
Yeah, sure. Thanks. Yeah, Mihir.
Hello, sir.
Yeah.
Yeah, sir. Now that week 2 deadline has passed, if I have a doubt, we can discuss one PPA 2 in little bit detail, or that I
PPA2,
wanted to ask.
practice
Yeah.
programming assignment 2, right?
Yeah, sir.
Yeah, sure. Solution is also available, right?
Yeah, sir. Solution is available, sir. I wanted to ask, sir, how once we don't, when we don't have a solution, sir, how can we imagine, like, I think maybe this was the first question which I encountered with this, but I had difficulty imagining a solution with big O N plus R complexity.
Correct. Yeah, it's totally understandable here. So these terms, I believe you heard for the very first time in your life, right?
Yeah, sir.
Imagine when you started writing Python codes in last term.
Yes, sir.
Initial few weeks, I believe you must have faced a lot of difficulties even with writing for loops or while loops and so on, right?
Yes, sir.
But now I don't think you will have any problem with that.
Yeah.
So similarly, these complexities and all these asymptotic notation terms, right? Big O and this thing, that thing, you have heard it for very first time in week 2.
Yeah.
And that's what we are going to focus on during this entire course. So that's absolutely fine. Don't need to panic. It's understandable. It is complicated at a first place. Slowly, it will become a routine for you. Don't worry.
So, sir, can you like review the solution and tell us how do we calculate N plus R complexity in that?
Okay, solution of yours or solution of
of the solution provided by a user.
Okay. The solution which we provided, right? Yeah, sure.
Yes,
we can. Okay, hold on. I don't even remember what exactly the question was. Okay, okay, so it's ascending order sorting. Okay. So list is given and R is given. All right. So it's that. I mean, there are a lot of repetitive numbers in the list, and you just have to sort it and bring them together, right?
Yes, sir.
Okay.
Yes, sir. I understood the solution and I understood the problem also, but I faced difficulty connecting it to the complexity that was asked.
Yeah. So I understood your problem. Just give me a minute. Let me get that solution opened, and I will explain you.
Yes, sir. If you could share your screen, that will be.
Yeah. I will. Let me first open the file where it is, and then I will share my screen. Just give me a minute. Okay. Yeah. Is it visible?
Yes, sir.
Okay. So that's the sort in range definition of the function which you are supposed to write. You are supposed to code, right?
Yes.
Yeah. So can you tell me what is happening at line number 6 and 7?
Sir, in line number 6, we are just counting the list and updating its frequency in the dictionary, right?
Correct. Okay. So for how many times we have to execute this loop?
The number of elements in the list.
Correct. That part is also correct. Then what is the complexity of that specific line number 6 and 7?
The length of the list, right? N.
N. So what we will call it? Big O of N, correct?
Yes, sir. Can you repeat?
Then what we will call it? We will call it big O of n, right?
Yeah.
Okay. Okay.
Yes.
Then let's move to next part, where that line number 10 to 13 are there. What is happening at line number 10?
Line number 10, we are going through the keys in the dictionary.
Correct.
So there will be R values, right?
Correct.
R values in the dictionary according to the question.
Absolutely correct.
Yeah.
So how many number of times that I mean, how many iterations will be there for that line number 10? R. Perfect. Then what is happening at line number 11?
Line number 11, we are
yeah, take your time, think about it. What is happening? Hello?
Hello, yeah, sir. I am thinking.
Okay, sure. Take your time.
I think, sir, it's is it editing the list with the new keys?
No, I'm not asking about line number. Forget about line number 12 and 13. 12 and 13 are not relevant here. I'm asking about line number 11. Specifically, what is happening at line number 11? Some another loop is there, right?
Yeah.
Yeah. So what exactly that loop? I mean, how many times that will execute?
It will execute according to the frequency of that number, right?
Correct.
So that this will be variable according to what's the frequency, right? So
correct.
If there are three zeros, it will be 3. The range will be 3.
Correct.
Yeah. So 0, 1, 2. So, sir, how will we factor this into the complexity?
Correct. So your individual something called as step count, right? The place, I mean, the mechanism which decides how many number of time each line is going to execute. That part you are understanding. Then finding a generalized complexity of entire code is the just one more step after that. Okay.
Yeah.
So what is happening is this particular first line number 6 and 7 is for n that you understood. And this is going to execute for R times.
Yes, sir.
And this operation is going to happen, this line number 10 for R times.
Yes, sir.
Correct? But within that R times, how many times this will happen? We cannot predict that. As you said, right? It will be a variable. It can be it can even be 1.
Yeah.
Right?
Yes, sir.
So considering that uncertainty with this thing, but it's most of the time, if you observe the inputs or so, right, this value is very minimal as compared to this huge n, because this is also somewhere in terms of it is it's very less than n, right?
Yeah, sir, it was given in the question.
Correct. It is okay. It specifically must have been mentioned, right? It's very less than n.
Yes.
Right. That is the reason you can absolutely ignore it. Okay. But let's see, this is because that specific, that comparison is given as part of that's the question, right? So that's known to you. So now what are the important factors in the entire thing? This is n. Sorry, I'm just not getting highlighted every time, but yeah, this is n.
Yeah.
And this is R, this line number. So as line number 11 is very small and negligible, only n and R are the two major factors.
Okay.
Then what is the complexity?
Yeah, so n plus r, because the loops are not nested.
Correct. Absolutely. That's the logic behind it.
Okay.
It's simple, right? It's not that difficult. Okay. I mean, I understand at first level. I mean, you are hearing it for first time. That's why you are bit scared of, if I say you're a bit scared of it, but otherwise it's not that complicated. Okay.
Yeah, sir. After this,
I mean, even right now, if you see, right, majority of the part you yourself figure it out. Okay, I just helped you. It's
yeah,
not.
sir.
Yeah, so it's just that confidence will come as you keep doing it repeatedly over weeks during the course.
Yeah, sir. That will happen for sure. But and now that we have seen your review, we will be able to go through our code systematically like this.
Yeah, right. This is how you should do it. Just identify the lines or the blocks of code which will contribute to complexity. Contribute those specific portions complexity individually, and then try to bring it together and make it generalized for entire code.
Okay.
Yeah.
And sir, if we like this, we knew the solution, so we could review it. When we see the question and the complexity, so at that time, so like before the solution, I couldn't solve this question with regards to complexity. But after I saw the solution, like just after reading the first comment, like create a dictionary, the solution popped in my mind like very quickly.
Correct.
So sir,
it's a practice thing, right? It's a thought process which again it evolves over time, and which takes in fact much larger amount of time than just learning some concepts. See, complexity is just a concept which you can learn a few hours or maybe in a week or so. But this coming up with a logic is what you're gonna learn or practice, or you will evolve on this your entire life.
Yeah, sir.
Okay, logic is something it's just like studying, right? It never stops.
Yeah, sir. So
that is fine.
With time, I guess with time and more coding, our mind will develop some models, and then we'll just be able to apply it to the question.
Correct. So I will again ask you same thing. The same questions which you felt were difficult during previous Python course, right? Previous terms Python course. Now, do you find them equally tough?
No, sir. Now they seem trivial.
Similarly, similar things will happen with this as well. Okay.
Thank you, sir.
Yeah, sure. Okay. Is there anything? If any last question, we'll take it, or else we'll close the session.
So one quick last question.
Yeah, Cherian, go on.
Yeah. In week 3 videos of linked list, there were some limitations on what operations we can do on the head of a list.
Yes, correct.
Could you just explain what those operations are that we cannot perform?
Okay. Can you point me to exact lecture so that we can use some slides as a reference to explain? It becomes easier. So, do you remember which lecture exactly sir has said this?
In 6, designing a flexible list and operations on the same.
Yes.
3.6 and 3.7 both actually.
Yeah. Okay. Okay. So, okay, I have it. So let me share. Okay, this is the slide, that 3.6 slide, right? Implementation of list, this is done. Okay, the next point is appending a list. So this is where the operations start, right?
Yeah. So appending to the beginning, the head of the list.
Yeah. So I mean, it's not actually called append. I mean, you can call it, but
Insert.
when we say
Insert.
when we say append, it's at the end. When we call it insert, it's at the beginning.
Okay.
So insert at the beginning, it's not like a limitation as such. Of course, we can do this insert at the beginning, but it's tough. Okay. I mean, the way you do it, we will change, because your head pointer is pointing has to be recalibrated to your new node, correct?
Yes.
Which is not the case if you are inserting at anywhere else. So it's a limitation, it's an additional overhead, or it's a one extra space, which extra step which you have to do in order to do this insertion at the beginning. Okay. Or similarly, if you are doing deletion at the beginning, again there is that extra space, extra step. Because if there is a deletion at some other place, you can simply do, if let's say I am deleting the last one, the easiest one is to make the second last nodes pointed to none, correct?
Yes.
Just it's a small one single step. Whereas I cannot do that for first with head. If I am going to delete the head, there is nothing behind this and nothing before this which I will make it null. So what I have to recalibrate this head pointer from V0 to V1.
Okay.
So it's not about just making some value none. The computation is different. So your insert has to be, when you say implementation of it, right? If I implement one method in this particular node class, which is delete. Okay. And then what I will do, I will, let's say, whatever I will receive some node, I will say node dot previous node dot previous dot next is equal to none.
Okay.
That means for example, I'm saying I'm trying to delete this one. This is my current inserted node. This I will receive as a parameter, right? Input parameter, because I want to delete this. So what I will do, I will go to previous of this and
delete the pointer.
Delete the pointer. Not delete, I will make it null.
Null. Okay.
So it's just single one assignment. Whereas if I have to implement same delete function, and instead of passing this v of n minus 1, instead of that, if I pass v0 to it, can I implement same strategy?
No, you can't.
You can't,
because
right?
There is nothing before that.
Correct. So limitation is in that sense that your logic will vary depending on the which element you are trying to delete, or where you are trying to insert. So your implementation logic will vary depending on the location of that particular node. And if it's a head, then it has to be different as compared to anything else. So you'll have to have 3 such logics, one for head, one for tell, and one for intermediate one.
Okay.
So so limitation is not a right word. Only some extra care has to be taken in order to do those things with respect to head. Because if you lose head, you lose entire list.
Because the variable name points to the head.
Correct. So if you somehow messed up with that, all your values will remain there somewhere in memory, but you will not have no way to access those, even though they're there somewhere.
Okay.
Okay, so it's like it will be like a lost chain of values which are there, but you don't know where you have kept. It's like, it's like keys. You have a big bunch of keys, but you have lost them. So something like that. So this is what I mean. In that case, you create this and then you create a pointer. Yeah, that's what Sir has explained. But the point is, what I'm trying to tell you, don't call it limitations. It's a extra care which has to be taken in order to deal with head, with any kind of operation when head is associated with it.
Okay.
Yeah.
Thank you, sir. I understood this.
Yeah. Okay.
One doubt regarding this. Insert doesn't need to be at the beginning, it can be in the middle as well, right?
Yes, exactly. In the middle also. For middle, there is one more logic will be applicable. I mean, you cannot apply same logic which is applicable to head to middle.
But insert word is not used for inserting at the end, right? That's only for append.
Sorry, yeah. So when we say append, it's at the end. Insert can be at the beginning or in between. Okay. So this particular insertion is at the beginning, right? What you see in the slides at currently. Okay, let me go down the slides. I think there is an example where sir showed the insertion at the middle also. Okay, if not in slides, I think that it was there with his annotation. I think he explained. That's why it did not appear here, or maybe different lecture. Okay, fine. Anyway, I will explain you. What will happen if I'm supposed to do insertion in between V1 and this Vn minus 2. This is the place where I want to do insertion. Then what will happen? I will have to change 2 pointers, right? I will create that node. This pointer will, from here, it will come here to this V, and this pointer will go here. But still, we are not doing anything to head. There is a difference between head and all remaining pointers. See, this logic is still same. You have to insert and change the pointers. That logic is same. The point I'm trying to make here is there is a difference between all other pointers, initial pointer, which is this head, because that's where your insertion point is. I mean, without head, you cannot do anything with respect to linked list. Okay. Hello. Am I audible?
Yes, you are audible, sir.
Okay. So who asked the question? Oh, Cherry and Maitri, I'm here. Okay.
Hello.
None of you asked, right?
I think Mehak asked the question, but she got disconnected.
Yeah, she got disconnected. Oh, okay. Okay, fine. So maybe if she joins, we'll wait for 2 minutes, or we'll close. She can ask maybe again also in next session. But this part is clear with you all guys, right? I mean, 3 of you, it's clear with you, right?
Yes, sir.
Okay, fine. All right, then maybe we'll close. We have already crossed the time. I mean, Mehak can always use Discourse, and I mean, we have anyway, live sessions will keep happening. So, all right, then we will close. We'll have a live session on Saturday, which is that live coding session. So you can join and practice more questions on Saturday. Okay, thank you guys. Thank you for joining.
Thank you, sir. Thanks.
Yeah, thank you.